Alright, this section is actually section 11.2 in the book, and it's arithmetic sequence. So in an arithmetic sequence, the difference between consecutive terms is the same. So this is an arithmetic sequence because I'm adding 5 every time. This is an arithmetic sequence because I'm adding -2 every time. So it's in a pattern such that when you subtract the second term minus the first term, and the third term minus the second term, and the fourth term minus the third term, you're going to get the same number every time. So there's different ways that you can write an arithmetic sequence. You can write an explicit formula. So the explicit formula looks like this. A sub n, so to find the nth term in the sequence, you take the first term, probably should have left more room over here, and then you add the difference times the quantity n minus 1, where n represents a certain term. So if you're trying to find the fourth term in a sequence, you would do a sub 4, which represents the first term, equals the fourth term, equals the first term plus the difference times 4 minus 1. So n represents the nth term. So this is the explicit formula. The recursive formula is 2 lines for the formula. So in a recursive formula, you need to have a start. So your start is a sub 1 equals the first term. So whatever a sub 1 is. Then to get the nth term, you're going to do something with the previous term. So if a sub n is the term that we're talking about, the previous term is n minus 1. So it's going to be n minus 1, a sub n minus 1, plus the common difference. So this is the explicit formula. This is the recursive formula. So to use the recursive formula, if you're trying to find, let's say you're trying to find the 34th term, you can't just plug in 34 in here, because if you plug in 34, a sub n minus 1 is going to be a sub 34 minus 1, which is the 33rd term. So you're going to have to know the 33rd term. So the explicit is one way, easy way you can find the 34th term. The recursive way, you'd have to get the first 33 terms. So to figure out if a sequence is arithmetic, what you need to do is see if it's going up by the same amount. So if you see here up or down, this is going up 3, so yes, it's arithmetic. And find the common difference. The common difference, I'm going to do 10 minus 7, which is 3. Okay, and the second one, it looks like the recursive formula. So I'm going to show you just how to write this out. So a sub 1 is 7. So what I'm going to do to find a sub 2 is I'm going to take a sub 2 minus 1, which is a sub 1, and add 4. So I'm just going to add 4 to 7. Then I'm going to add 4 again, because that's what the common difference is. And I'm going to add 4 again. So yes, it's arithmetic, and the common difference is 4. Number 3 is a geometric representation. So what I'm going to do is I'm going to write how many dots are in each one. So this one has 3 dots. This one has 6 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This one has 10. So it's not arithmetic because I'm not going up by the same amount. Even though I'm going up 3, up 4, and this is probably going to go up 5 to get the next term, it's not arithmetic because it needs to be going up by the same number. And then number 4 is yes, the common difference is -3. I'm going down 3. Number 5 is up 3, up 2, up 5. So no, you're not going up by the same number. And then that's it. Number 6, find the missing term of the arithmetic sequence. So you're trying to find a term in between these two. This is called the arithmetic mean. So there's a geometric mean, which we'll do later, and there's an arithmetic mean. So to define the arithmetic mean, what you're going to do is you're going to average these two numbers. So you're going to do 50 plus 92 and divide it by 2. And it's 71. So 71 is in between. So let's just check it. So if we put 71 right here, the common difference is 11 and 11 right here, so it's good. So number 7, I'm going to do 24 plus 57 and divide it by 2. So 24 plus 57 divided by 2 is 40.5. So this is 40.5. So this is called the arithmetic mean. Write an expression that shows the arithmetic mean of a sub 6 and a sub 7. So to find the arithmetic mean, you add these two and then divide by 2. So this is an expression. And then number 9, use the explicit formula to find the 25th term in the sequence. So to find the explicit formula, I am going to write the formula down. So it's a sub n equals a sub 1, which represents the first term, plus d, which is the common difference, times n minus 1. So I need to fill in this number, a sub 1, and d. Just like when you're writing something in slope-intercept form, you find the slope in the y-intercept, you need to find the first term and the common difference. Think of this as almost being like your y-intercept and this being your slope. So to find a sub 1, that's pretty easy because it's my first term. So a sub 1 equals 5. And then my common difference is going to be 6. So d equals 6. So first I'm going to write my formula. A sub n equals 5 plus 6 times n minus 1. That's my explicit formula. Now be careful that you don't combine these and write 11 times n minus 1. This 6 is stuck with the n minus 1. These are not like terms to add them. So to find the 25th term, I want to show my work and do a sub 25 equals, that represents the 25th term, 5 plus 6 times 25 minus 1. So you're going to do 24, because 25 minus 1 is 24, times 6, and then add 5. And the 25th term is 149. Number 10, find the 3rd and the 10th term of the sequence. So this is a recursive formula. So the first term is 5, and then we're taking the previous term and we're adding 6. Because remember, a sub n minus 1 means previous term. So if I find the second term, I'm just going to show you how to use this formula here. It's a sub 2 minus 1, which is a sub 1 plus 6. So this is a sub 1, and you're adding 6, so that's 11. To find the third term, you do a sub 2 plus 6. So I'm going to add 6, add 6. So you can just keep adding 6 like this. If this is a very high number, like anything, let's say like 12, even higher, what you could do is take what you have so far and write the explicit formula and then plug in that higher number. I'm just going to keep going because adding 6 is not too difficult. So this turns into 29, this is 35, this is 41, 47, 53, 59, 65, so I got, maybe I went too many, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so 59. So here's the third term, here's the 10th term, but remember if you go higher, I would write the explicit form. Rewrite as a recursive formula. So let's look at, I'm going to generate the first few terms of the sequence. So the first term is 3 plus 2 times 1. So the first term is 5. So a sub 1 equals 5. And my formula is 2 lines for a recursive sequence. So I have a sub 1 equals 5. Then my nth term can be found by taking the previous term plus the common difference. So I'm going to generate the next one, plug in 2, and I'm going to get 3 plus 2 times 2, which is 7. 3 plus 4 is 7, so a sub 2 equals 7. So my common difference is 2, so I'm going to add 2. So here's my formula. Just like I had to find my first term in explicit, I need my first term. And my difference is I'm going to do the previous term plus the difference. And if the difference is negative, just put minus that number. Number 12, suppose you already have saved $75 towards the purchase of a new iPad. You plan to save $15 a week from money you earn at your part-time job. In all, what is the minimum amount you'll have saved after 26 weeks? So we have a sequence. We have the first term is 75, and the common difference is 15. So I'm going to use my formula a of n equals a sub 1 plus the difference times n minus 1. So I'm going to plug in a sub n equals a sub 1, which is 75, plus 15 times n minus 1. But now I want to plug in 26, so I'm going to plug in a sub 26, which represents the 26th term, equals 75 plus 15 times 26 minus 1, and I'm going to calculate that. So I get $450. So minimally, I'll have saved $450.